these are, I looked a little bit at your previous lesson, so we should be familiar with such graphs, quadratic graphs. So let's see what it takes for us to sketch this graph. Right. So all we're going to do is substitute the points given to us over here into my equation of the graph, which is fx is 2x squared minus 1. Hello, Theo. Welcome. So let's get substituting, okay? I'm going to have, for my first one, fx, bad habit of saying y, but fx is equal to 2 times 1 squared minus 1. Now, this is just going to give us 2 times 1, right? Because 1 squared is just the 1. 2 times 1, which is a 2. And if I minus 1, this is going to give me a 1. Wonderful. That's our first point, done and dusted. Okay, let's substitute the second one quickly. F of x is equal to 2 times 0 squared minus 1. This whole part will just be 0, okay? Because anything times 0, just 0. So now I have 0 minus 1, which gives me a negative 1. Okay, last point was a negative 1. So f of x is equal to 2 times negative 1 squared minus 1. What is negative 1 all squared? If my negative is inside the brackets, guys, what is that going to give me? Negative 1 all squared, just like we have here, over here. Negative 1 squared, nice, Sanele, it's positive 1. So this is actually 2 times a positive 1, which is 2 minus 1. And that is the same answer that we got for the first one. So I don't know how familiar you guys are with this graph, but you guys should have known this was going to happen. Okay, so let's pull out our points. It is a smiley face. And how did we know that, Abu? I know there is a way that you guys know that. So we have a negative 1. Because of the 2, what about the 2 is telling us that it's a smiley face? You're correct. Nice, Abu. It's positive. Okay. So if the number, your coefficient of x squared is positive, then we already know that this is going to be a smiley face graph. So when x is 0, we found that my y is negative 1. And then when x was negative 1, my y was positive 1. So we're just playing with ones here. There's a lot of ones going on. As well as when x was 1, this is a positive 1. Okay, now, before I move on here, we will not be judging one another on our sketching skills, people, okay? Just forgive me. I'm going to apologize in advance before I even start sketching. You guys will be okay. Just use your imagination. Okay? Now, let's see. Whew. Nope, that was so close, but so far, so I'm going to move it. Okay, and over here. Boop. That's not bad. That's not bad. Okay, thank you, Narisha. That is much better than the last time I tried to draw a graph. I'm going to blame the digital space, guys. I draw very nice graphs on paper, but now drawing with this digital stuff is a lot for me. Okay. As long as we can see what it's supposed to be, Abu, don't worry. All right. Now, today we're going to be speaking about a few of the terminology that comes with these graphs. I know some of you might know this, some of you might not, which is why we are discussing it today. It's important to use the correct terminology when doing these graphs. Hello, Vukosi. It's okay. Welcome, welcome. Okay, so we're going to discuss a turning point, my x and y intercept, as well as the domain and range. So some of these will be familiar to some of you guys. So let us get going. So I have a graph, equation of a graph over here. Y is equal to x squared minus 9. I'm going to speak about these as they relate to the graph, or how we find them on the graph, obviously, and how we would find it using just the equation. Okay, so that's very much possible as well. So my step one, I'm going to sketch this. I'm going to use 3 points just to sketch it quickly. Okay, so I'm going to write for x is equal to, let's say, -1. For x is 0, and for x is +1. Okay, my first one, if x is -1, what is my y? Will be -1 squared minus 9. You guys said -1 squared is equal to +-9, so it's -8. Beautiful. This one is 0 squared, which is just a 0, minus 9, -9. And the last one is, what do you notice about these points all the time, guys? When we have opposite x values, what happens with the answers? It's happened twice now, and you guys should have seen it in other times when you're drawing graphs. What happens with the points that are opposites of one another? It's symmetrical. Thank you, Abu. Will that always be true? Will that always be true? Oh, Abu says yes. I'm going to leave that question up in the air. I'm going to leave it up in the air. Okay. So since our graph is a little bit limited here, I'm going to put my -9 here. Guys, remember, if it's a sketch, you do not have to write all of the points. Okay, I'm just going to put a -9 there. I'm just going to put a -9 there. But it doesn't necessarily mean that point is -9. Well, it is, but you guys get what I mean. Okay. So my first point is over here. And then we have a -1 and +1 with 8. So my -1 with my 8 over there, and my +1 with my 8 over there. And then my graph is just going to go up. Okay. I'm going to address the whole symmetry thing just now after I draw this. Whew. The right hand side is always great, guys, but wait until I get to the left hand side, then it shakes. Okay, I was doing so well. Ah! Last chance. Nope, that wasn't my last chance. That was horrible. Okay. Where is Michael Jackson? Maybe that's why I can't draw a graph. Yeah, you guys are gonna have to use your imagination. You get the point. Okay? Now, let's talk about this terminology. Firstly is my turning point. What is a turning point, my lovelies? What is a turning point? It is Q, but let's say we're speaking about the graph. The current graph. Let's say you don't have the equation. Then my point is -9. It is the point where my graph turns. If you look on the left of your turning point, the direction of the graph will always be different from the right of your turning point. This is what I mean. On my left of this specific turning point, was this an increasing or decreasing graph? On the left-hand side of my turning point, it was a decreasing graph, okay? And we know that because my y values were going down and down and down, okay? So it's decreasing y values, not x, okay? And then if you look on the right-hand side of this graph, it is now an increasing graph because my y values are increasing. So that change in direction means we have had a turning point. Okay, we have had a point where your graph is turning. So it either goes from increasing to decreasing or from decreasing to increasing. And as Abu has told us so nicely, we can find that value by looking at Q. Now, for people who might not know what Q is, what is my general equation for this graph? y is equal to ax squared plus q. This q tells us a lot of information about my graph. Okay, it could tell us my turning point. What else can that graph tell us? What does -9 mean? I have moved my graph 9 units down. Do you guys get it? This is your vertical shift. There is a horizontal shift, but I'm just not sure whether you do it in grade 10 or not. So I'm just going to keep quiet to not confuse everyone. Okay, so Q tells you your vertical shift, and it also tells you where your new turning point will be. All right, because if Q is positive, that is the vertical shift. Pumzile, it's vertical or Y. So if Q was +4, that means your turning point went from 0, 0 to 0, 4. Okay, the best thing you guys can do for yourself is learn what the mother graph looks like. That's the graph that is just y is equal to x squared, and that's this one. Okay, my original turning point is 0, 0. So if I've had a y shift or a vertical shift, if I move down, let's say I move down 3, then obviously my y coordinate will be -3. And if I move up 7, then my y coordinate will be a +7. Okay, so you guys know what the turning point is. You can find it by A, looking at your graph, but if you don't have a graph, you look at the Q value, which in this case is -9. All right, now let's talk about X and Y intercepts. I know you guys know these really well. What are my X and Y intercepts? Let's start with Y. Let me move this graph down. What is my Y intercept? Nice. My y-intercept just for this specific case is the same as my turning point. Or the point 0, -9. Will it always be the same as the turning point? What do you guys think? No. I told you guys there are horizontal shifts, but we're not speaking about them today. Okay. What I mean is it's possible if I have moved my graph, let's say that way, and my turning point is now there, do you see is not the same as my y-intercept? So you must be careful. Just look at your graph. But if you haven't shifted it, then yes, it's the same. How do we find the y-intercept if we don't have a graph? I saw you guys did this in the different lesson, in a previous lesson. Dual intercept? No. How do I, if I only have y is equal to x squared minus 9, how am I going to find my y-intercept without a graph? Anyone? Look at the formula and x squared minus 9. Substitute what, guys? What do I substitute? 9 into what? But remember, you don't know the intercept, Abu, remember? My question is, if you didn't have the graph and you didn't know your intercept, what would you do? You make x 0. Nice, Abu. So for your y-intercept, I'm writing notes everywhere here, guys. This shows you how I study. For your y-intercept, your x has to be 0, which means to find your x-intercept, which one must be 0? Your y must be 0. Okay, guys. And we don't need to do that right now because there is a dual intercept. Insect. In this case, you can't see it because I drew my graph terribly. So let's work it out. What are my two intercepts for this graph? if my equation was this, and you guys said I must make y 0. So 0 is equal to x squared minus 9. Someone set it up there. We need to solve for x. Hlulani, your suggestion is coming into play here. How am I going to find my 2x values in this case? As in, how will I solve for x? You can do the additive inverse. There's just one trick with that. So let's do it. Let's do it. Okay, Sanele, let's do the additive inverse. So let us say x squared is equal to positive 9, right? Which is taking this. Yes, Lulani, that's what I was looking for. We'll do it just now, though. Okay, but what happens if I square root? What do you have to remember when you square root? If I introduce a square root into a question, then what do I have to remember? If I'm square rooting these two sides, there's one thing I have to remember. If I just write this, is this correct, guys? Is this correct, though? No, what's missing? There's only one thing missing here. It is the plus or minus, guys. You see why this one is dangerous? If I just say x squared is the positive square root of 9, then I'm going to say, therefore, x is 3. And that's only one solution, which means you will miss out on this solution. Be careful. So if you are going to introduce a square root, you need to remember to do plus or minus. Yes, Abu. It's two solutions. So x is either positive 3 or x is negative 3. Okay, that's why difference of two squares is a little bit safer, because let's do difference of two squares. X squared minus 9 equals 0. What are my two brackets here for difference of two squared? However, as long as you don't forget to put that plus minus, you will lose mark for losing that one solution. Okay, you can see from the graph that you should have two solutions. Thank you, Abu. X plus 3 and x minus 3. And after I have my two brackets, I can split them up. So either x plus 3 is 0 or x minus 3 is equal to 0. So what is my first solution going to be? Therefore, x is equal to negative 3. Thank you. Or x is equal to positive 3. Okay. So whoever suggested the inverse operations and square rooting, you're totally correct. Just remember to do plus minus. And I don't know if I told you guys this before, but if you introduce a square root to a question, you always do the plus minus. Okay. What I mean is, if you have a question, let's say the question is y is equal to square root of 16, then that's fine. It's just square root of 16. But if your question was y squared is equal to 16, then when you square root, you better put plus minus. Okay, that's because this has two solutions. Negative 4 all squared is a negative times a negative, which is why it gives you a positive 16. Do you see why? So remember, if you are the one introducing a square root, you have to put plus minus. But if it was there in the question initially, then you do not have to do it. All right. So there are intercepts. And since this was a sketch, it wasn't in scale. But now I know, after working this out, that this point over here is negative 3. And this one over here is positive 3. Okay. Now we move on to domain and range. What are my domain and range, guys? I know this is a lot of information, but you guys will have to just forgive me. What is our domain and our range? Domain is x values, but what about them? It tells us something about the x and y values. So my domain, I'm first going to write it here. Domain is the set of x values, and your range is your set of y values. Okay. Now let's look at this graph over here. What does my two arrows mean? What do these two arrows at the end of this graph mean? These ones. What do those mean? It means it keeps going, okay? Not only does it go up and up and up, do you see that it goes wider and wider? The graph is not like so, it is like so. So it gets wider and wider and wider, which means, will my x values ever stop for this graph? No, they won't, because it keeps getting wider. Do you see on my left-hand side, it's going to keep going to negative and negative and negative infinity forever and ever. There is no point where it's going to stop. And on my right, it's going to keep going to positive infinity, as in it's going to keep going wider and wider. So then, for this specific graph, what is my domain? We just established that it's basically all the numbers ever, right? So what will be the domain for this graph? Where does this graph start and end? You can either say for domain, x is an element of real numbers, so it's all real numbers, or you can write it as so. X starts from negative infinity to your positive infinity. Okay, why did I say real numbers and not natural or whole numbers? Why did I say x is all real values instead of all the natural numbers? Because it's everything. Thank you. It can also be decimals. It will also be fractions. Wherever I go on this graph, if I choose a random point over there, if that's -1, that's definitely less than -1. Right? Greater, actually, because it's negative. Like over there. If that's 1, that's less than 1. So it could be 0,5. It could be 0,73334. We don't know. But the point is this one also has a point on the graph. So x is all the real values, all of them. Is it the same for your y values, which is my range? Is it the same for the y values? Yes, no. No, it's not, because why? There we go. It starts at -9, so it's not the same. So for my range, you say we go from -9 all the way to positive infinity. So you can literally just say my range, where is it? Y is greater or equal to -9. I say or equal to because there is the actual point on -9. Okay. This was a lot of information. Like a lot. So I zoomed out. If you want to take screenshots, can I have a thumbs up, thumbs down? Are we all good with everything we discussed today, which is a turning point, x, y, intercept, domain, range? For those of you who are lost, give me one of these if you understand on reactions, press reactions in one of these, and one of these if one of these things are not clear, if you don't understand. So can I have a thumbs up or a thumbs down? There are 17 of you in here. Oh, sorry. There you go. There we go. There. Jeez, I wrote a lot. There we go. Is that better? Wonderful, guys. That's better. Now you need to respond. I know we're tired, but you need to push. Okay. There we go. Hopefully everyone got all these screenshots and notes over here. Great. Now, there is another example, but I need us to start with the hyperbola. Okay. Before I start, is anyone in here who is familiar with the hyperbola? Abu says, oh no, just be positive, man. This is gonna go well. Don't worry. Anyone familiar with this? Princess, I'm not sure if the thumbs down means you're not familiar or if you don't understand the previous stuff we just did. It has an asymptote. Thank you, Abu. Thank you. Tenyuko says, I am familiar. Princess says, I have no idea what this is. It's okay, guys. It's okay. Okay. Let's discuss the hyperbola. I'm going to start off with drawing it. I think that's the best place to start with this thing. I'm going to start off by drawing it, and then we'll discuss asymptotes, quadrants, all of that. Okay. So I'm going to have a few points over here. You have to, Narisha. I'm going to have x is -2, x is -1, x. -1, 0. You guys are so negative. Oh, I can't believe it. Okay. So our equation is fx is 1 over x. So I'm just going to substitute the x values I have over here to my equation of 1 over x. So let's get going, okay? First one, fx is just -1/2. Simple, right? Second one, fx is -1, well, 1 over -1, this is -1. Now, let us look, guys, let us look here. X is equal to 0. I'm going to substitute it, but I want you guys to tell me something about this. 1 over 0. What is the problem? Wow, Haibo, Abu, what happened? It is undefined. So do we actually have a point there? Do we have a point? Nope. Okay. See, substituting is fixing a lot of our problems here. Thank you, Abu. 1 over 1, this is 1. And fx for the last one is 1/2. Wonderful. Okay. So let's try and plot this thing here. When x is -1, y is -1. So my point is here somewhere. Okay. My first x was 2 for out there. And -1, so it's over here. Interesting. All right. The next one says, when x is -2, y is -1/2. So it's over here. It's getting closer and closer. Do you guys see that? Right. Now let's go to the other side. 1 and 2. When x is 1, y is 1. What's going on? Do you guys see a point? Yes, then you go. That is correct. I saw your message and that is correct. And then the second one, if x is 2, y is 1/2. Now you guys are probably thinking, how on earth do we draw this graph? Okay, I'm going to add another point here, which is x is 1/2. And there's a point, there's a reason I'm doing that. I want you guys to see what this thing is doing. When x is 1/2, y is going to be 1 divided by 1/2, which is the same as 1 times 2, which is 2. So when x is 1/2 over there, y is 2. Do you guys see sort of what this graph is supposed to look like? X is -1/2, y is 2 over there. Okay, so I'm going to draw it. Okay, I'm going to draw it. I'm going to ask you first, can x be 0? Abu said that he knows where I'm going with this. X can't be 0, right? So it cannot touch my y-axis. But it gets closer though. If you're looking at these points, it is getting closer and closer and closer to my y-axis, but it will never touch. So this graph looks like so. Nope. I started off well and then I went south. Nope. Okay, I'm gonna start here. Like so. Like so. Pretend this point is on the graph. And then on the other side, yes, it looks like two separate graphs. That's just life. There and there. Okay. So the first thing we need to notice about this graph is it gets closer and closer to here. But will it ever touch these? No, it won't. Okay. It will never, ever, ever, ever touch them. Okay. Now, these points or these lines where it will never, 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 never touch. What do we call those, Abu? I know you know. We call them asymptotes. So there's my first definition, okay? My asymptotes. Those are the points where, or it's actually not points, those are lines where the graph will never touch. Okay. A line where graph approaches but never touches. Hey, English is charming me. It's killing me. Approaches but never touches. All right. Are we with me, guys? So we have now established what our asymptotes are. Now, for a ordinary graph, now I'm going to start using my general formula. Y is equal to A over X plus Q. For a graph where there is no Q, then your asymptote will be Y is equal to 0. Okay, I'm not going to talk about the horizontal shifts yet. Right now, we're only speaking about vertical shifts or up and down. So if you look at this graph, okay, fx is equal to 1 over x. Did we have a q according to the general formula, which is y is equal to a over x plus q? Was there a q in this graph? No q. So that's why your asymptote is y is equal to 0 or my x-intercept. I mean, my x-axis. My brain is tired, guys. My x-axis. Okay. And then we've also established that x cannot be 0, which means your y-axis is also an asymptote. Okay, guys. Now, moving back to this equation, what does A tell me about this graph? Currently, we have A that is a 1. Okay, I'm going to highlight in the same thing. A is 1. What does it tell us? If we don't concentrate, we were not going to get this. Okay. What does A tell us about this graph? I'm only going to tell you there's a lot of features, but all I'm going to say is if A is positive, first let's number my quadrants. Okay. I don't know if you guys remember quadrants. You should have done them in Trig. You did. I remember. So it's first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. Now your hyperbole will always be, or hyperbola. Now I'm going to English, guys. My hyperbola will always be in 2 quadrants unless there is a restriction. Okay. So if A is greater than 0, as we have just seen, then it will be in quadrants 1 and 3. But if A is smaller than 0, then it'll be in quadrants 2, and 4. Okay, in this case, my A was positive, greater than 0. Hence, my graph was in quadrants, if you look carefully, 1 and 3. Okay, guys, I know this is a lot of information. How are we doing with this? Let's have a thumbs up, thumbs down. There's a lot going on here in the chat. Thumbs up, thumbs down on what we know so far about hyperbolas, not hyperbole. No problem, princess. Where did I lose you? I can definitely go back. I know if this is a new concept, it's a little bit difficult to grasp. How far back would you like me to go? By A. Okay. So, princess, I don't know if you remember when you did trigonometry, we did quadrants, right? We start numbering these quadrants from my top right. Well, our top right, which is over here. So that will be quadrant 1. Okay. And we go anti-clockwise. So it's quadrant 1, quadrant 2, quadrant 3 here, and quadrant 4 just below quadrant 1. Okay. So I am saying if A, or the number above your X, do you see here X is in my denominator? If A, this guy, is positive, okay, maybe A greater than 0 is what's confusing you guys. So let me just say if A is positive or greater than 0, negative. If A is greater than 0, then your 2 points or your 2 lines of the graph, do you see this graph is made from 2 separate lines? They look like exponential graph, but there's 2 of them. Okay, so if A is greater than 0, your graphs will be in the first quadrant, which ours is. Look where it is there. And the third quadrant. But if I had gotten an A that was less than 0, what I mean is if my equation was y is equal to negative 4 over x, then I know that it was going to be in quadrants 2 and 4. Does that make sense, princess? I hope so. Wonderful. Okay, guys, you're welcome. Can we have another thumbs up, thumbs down? I didn't see it because I was helping princess. What do you guys think? Another thumbs up, thumbs down on the hyperbola. Obviously, you're not going to remember everything, especially if this is the first time you encounter this graph. But do you at least understand what I have said? That's what I want to know. Just give me a thumbs up, thumbs down on that. Okay. All right. I know it's a lot. It's quite a bit, hey? It's quite a bit. Okay, we're thumbs upping. Okay, so we have 3 graphs that we're supposed to draw here. And I know that's going to be a lot of it for us. So I'm going to just be forgiving and I'm going to erase the other one. Guys, Teacher Goko didn't put a brain break for you guys. Unfortunately. I can find one, maybe. Perhaps, if you guys miss it. Let me pause this. Okay, let's see. Who wants to talk to me for the brain break? Let's have hands up. Abby's already answering. Guys, we need someone to talk to me in order for this to be fun. Otherwise, it's not fun. Let's hear. Anyone want to raise their hand? Would you guys rather have a year of summer, a whole entire year of summer, or a whole entire year of winter? Because it's like summer. A year of Asanda, have you forgotten how hot we were this year for summer? You guys are happy now that we're cooling down now. Do you guys remember what this year's summer did to us? We nearly died. I remember just Oh, sweet. I don't know what to do with myself. Because he's like, Nkaloma wind. Okay. Exactly, Abu. Yo, it was bad. This year was particularly bad. The summer was hectic. I hope that doesn't mean the winter's gonna be worse, because then I'll cry. I don't know about that, man. Okay, next one. Would you rather be a dog or a cat in your next life? Hi, Bo Pumzile, where do you live? Huh? Yes, Narisha. I think I pressed unmute. There we go.
Hi, ma'am.
Yo.
Ma'am, I wouldn't want to be a dog, although I love dogs, but I would rather be a cat.
Why?
Because if, if a random child, because we get those random children in the street, walked up to me and then threw me in the sky, at least I could land on my feet. And also, I can happily walk down the street and not get, the word that we always say when we see a dog, that
Oh my
food.
goodness.
Uh, so I don't want to be told that
Wow.
to me. And if I have a happy family, I can just lounge on their couches and eat their food. It's
I
fine.
was about to say I would be a cat only because I'm an introvert. I don't want to deal with people, guys. Exactly, Vukoti, that's my problem. Everyone loves dogs. When they see a dog, they're all like, "Eh." But with a cat, IV, language, please. Thank you. Okay. So, yeah, I wouldn't want to be a dog because everyone's gonna on me. And then, at least with a cat, people are like, oh, cats don't like people. Just leave them alone. Yeah, that's what I want. That's what I want. See, guys, let's see the next one. Would you rather swim with eels or sleep in a cave that has bats? What do we say, guys? You're gonna either swim with eels or sleep in a cave with bats. That's fine, they are blind, but some of us are scared of them. Yo, guys. Eels are hungry and some are electric. This is true. This is true. I was like, maybe I'll be Batman. Yeah, but guys, I'm afraid of bats, so I don't know. I don't know. I don't know, guys. I'm, I don't know. This one's too difficult for me. The next one, would you rather only watch comedy or only watch horror forever? Forever and ever and ever. You only get to watch horror or you only get to watch comedy. Hi, guys. Everyone's saying comedy. Oh, Asanda says horror and Abu. Guys. You guys have interesting answers. Kevin Hart is hilarious. I don't want to lie. I'll get used to being scared. This is true. You're gonna desensitize yourself. And eventually you'll just be like, oh, okay. And the last one, would you rather compulsively laugh when you're sad or compulsively cry when you're happy? Like out of nowhere. When you're sad, you just burst out laughing. Or when you're sad, you just burst into tears. I mean, when you're happy. What? I'm mixing them. Wait. Compulsively burst out laughing when you're sad or burst into tears when you're happy. Whew. Guys, laughing is scary. Have you seen those people who laugh in like serious situations? Like those people, you would never know how to react. Or like in a funeral, guys, imagine bursting out laughing at a funeral. Come on, guys. Oh my goodness. Oh my gosh. Okay, guys, I gave you a brain break. Are you guys happy now? Can we go back to, can we do one more sum and then we can all go home? Imagine crying at a, hey, Pooms, imagine. Ah, guys, guys, there's a lot going on here. Okay. We're going to do one more graph, just one more. Okay. Using these concepts that we have now spoken about over here, asymptotes and quadrants. Okay. Now, h of x is equal to 3 over x plus 1. There's a reason I'm highlighting the 3 and the 1. And why is that, guys? Why am I highlighting the 3 and the 1? Because those are going to tell us important information about our graph. Firstly, where is my asymptote? Where is my asymptote? We know that there hasn't been a horizontal shift. So the first one is still x equals 0. But what about the y1? Nice, Abu. And how do you know that, Abu? How do you know that your asymptote is positive 1? Because it's the Q in my formula. Do you guys see this? This guy over here, that means my asymptote has moved up 1, which means it's over there. Okay, so I'm going to try and draw it as decently as possible. There we go. There we go. And then you write here that y is equal to 1. Okay, just so the teacher knows that this is your asymptote. All right, now which quadrants do you guys think my graph is going to be in? If you're not sure, I always say substitute. So just think, if you put a 1 over here, it's going to be 3 divided by 1, which is 3, plus 1 is 4. So where does that put me? I have a positive a value. So is it going to be quadrant 1 and 3 or quadrant 2 and 4? Which quadrants is my graph going to be in? Nice, princess. And why is it in 1 and 3? Why is it in 1 and 3? Because we have a positive value. See, guys, that wasn't that bad. Okay, so if you're going to draw this, the only thing I'm going to say now is be careful not to be tempted to draw it here by your x-axis, because your new asymptote, my asymptote, maybe I should highlight it yellow so you can see where it is and where this graph is going to be. Okay, this is my new asymptotes. That means the whole graph has moved up 1, which means it is more over here. And that also means that the second part of this graph will cut my x-axis because my x-axis is no longer my asymptote. Do you guys see that? Make sense to you guys? I have one more question. For a graph that I haven't moved sideways, do I have a y-intercept? For this graph and the one before, I haven't moved them sideways, right? Do I have a y-intercept? Will this graph ever cross my y-axis if I haven't moved this graph sideways? No, it won't, because it's an asymptote, and we just said asymptotes are not to be touched. Okay, but if I have a vertical shift. Nope. Is it vertical shift? If I have a vertical shift, then I suddenly have a x-intercept, because now my graph can indeed, do you guys see that it does cross my x-axis there? So you guys must just be vigilant. Okay, I think we're all tired, guys.